The element phosphorus, with atomic number 15, is located between silicon and sulfur on the periodic table. Comprising 15 protons and 16 neutrons, it is a highly reactive element and an essential constituent of materials and processes all around us. Phosphorus was discovered in Hamburg in 1669. It was there that Henrik Brand acquired it after the distillation of urine, while searching for the fabled philosopher's stone. These days, phosphorus is acquired from mining for phosphate rock, to be further processed and used in a great variety of products. Worldwide, only a handful of countries are responsible for the vast majority of the mining for phosphate rock. Yet there is an increasing demand due to growing populations and increased meat and dairy consumption. The European Union is highly dependent on imported phosphate rock, while quality reserves are declining, resulting in volatile prices in recent years. On top of this, phosphorus is a non-renewable resource. As such, sustainable development is needed. Within Europe, the European Phosphorus Sciences Network, PhoSciNet, is a knowledge platform to advance the undervalued potential of phosphorus in contemporary basic and applied research. Funded by COST, European Cooperation in Science and Technology, its chair and grant holder is located in Leipzig. The action incorporates 22 European countries and 1 institution from Russia, 70 research groups and industrial partners, focused into 5 working groups. Materials science and nanosciences, asymmetric catalysis, bioscience-related topics, novel high-potential phosphorus compounds for non-typical applications, state-of-the-art synthetic, spectroscopic and theoretical methods, working on a range of materials. One of the types of compounds investigated are pi-conjugated organophosphorus oligomers. When placing the substituents, the biphosphol rings twist and it may emit a green light. Upon replacing the substituents, the twist changes and the emission wavelength shifts towards orange. Associated with a blue emitter in an OLED structure, it will generate white emission, important for sustainable development of solid-state lighting. Another range of compounds investigated are the cage phosphonites. They form a new class of ligands, whose nickel complexes show promising results as catalysts for the hydrocyanation of butadiene to adiponitrile for the production of nylon, one of the most successful industrial applications of homogeneous catalysis. Urease inhibitors represent another important area being investigated. In bacterial infections, the enzyme urease catalyzes the decomposition of urea into carbon dioxide and ammonia, resulting in a local rise of pH with damaging consequences. The investigated aminophosphonates form a promising newly developed class of bacterial urease inhibitors. PhoSciNet has significantly advanced European scientific and technological expertise in the field of phosphorus chemistry, tangibly represented by 5 management committee and 4 working group meetings, 5 workshops and 1 international conference on phosphorus chemistry, 3 training schools, more than 45 short-term scientific missions, more than 520 publications in renowned scientific journals, strengthened existing international cooperations and emerging new ones, and an EU-funded training network on sustainable phosphorus chemistry called SUSPHOS. The European Phosphorus Sciences Network, advancing the potential of phosphorus in contemporary basic and applied research.